Hi, I'm Nicholas Fernandez. I'm a computational scientist at the Human Immune Monitoring Center at Icahn School of Medicine at Mount Sinai. And this video will walk you through a short notebook that visualizes a single-cell RNA-seq dataset that is publicly available from 10x Genomics. And we'll be doing this using a Kaggle kernel. So this link here shows you a static view of a short notebook that visualizes the dataset. So we can click the copy and edit button, and this will begin executing this notebook in what's referred to as a Kaggle kernel. So it actually starts up a computer on the cloud that has all the libraries that we need installed, including Clustergrammer2. And it runs a Jupyter notebook-like environment, and it's been running in Python. So it usually takes about 15 seconds or so for the kernel to become active, which it has done now. So what we're going to do is set the show widget variable to true to allow the widgets to be generated. And we're just going to run all cells in the notebook. So while the cells are running, we can see our workspace where we have preloaded some output data from an earlier processing notebook, which you have a link to at the top of the notebook. So in this notebook, we execute the cells. So we're executing all our cells, and we're basically doing two steps where we load our data set, which has been pre-filtered to only include the top 10,000 most variable genes and 2,700 single cells. So after we load our data set, we load it into, we see it's a pandas data frame, and then we just load that data frame into Clustergrammer2, where we proceed to, again, reduce the dimensionality to filter for only the top 250 variable genes across these 2,700 cells and z-score. And then we're just clipping the values to plus or minus 5. So if we scroll down here, we can reduce the size of our visualization of it. So we can see we have this heat map here that shows this view of our data set. So in this view, we have our cells as our columns. If you hover over a column, you'll see the cell barcode and a prediction of the cell type that was generated using the CyberSort signatures as a reference data set. So you can see that we have 2,700 columns, and if we zoom in, we can see the specific cell barcodes, and then we can see specific genes as rows. So if you hover over a gene, it will give you the gene name and the ref-seq information, and this is being done by talking to the Harmonizome project from Abi Mayan's lab. So what we see is in this data set, across these top 250 variable genes, we have a lot of structure. So we can see over here that we have a lot of what are predicted to be B cells as B cell memory, and then over here we have B cell naive. And we can zoom in and see specifically which genes are being upregulated in these cell types. And then we can adjust our dendrogram here and find different layers, or sorry, different levels of cell type clustering. So if we hover over here, it'll show us the breakdown of our cells like this. So we can see that this cluster consists of a lot of NK cells and different CD8 T cells and what are predicted to be gamma delta T cells. And so we can basically, Clustergrammer allows you to easily explore your data, and you can do things like reordering. So you can reorder all your cells based on cell type to help you visualize the structure. You could click a column in a particular cell and reorder all the genes based on the expression in that single cell. So you can see which genes are most highly expressed. And then you can also order just based on parameters across the entire data set. So we can put the rows in clustering order and rank cells based on gene expression, and start to see different patterns in our data like this. And so there's a lot more to explore, and we hope you enjoy the notebook.